allotropy or allotropic forms. Basically, the existence of a element, the existence of an element in different forms is known as allotropy, right? So the existence, or you can say, yeah, the existence of an element in different form is basically known as allotropy, right? Or you can say there are allotropic forms. There are allotropic forms, right? So as we know, like in my previous lecture, I told you about polymorphism. So polymorphism is basically is valid on compounds, right? It is valid on compounds, but this allotropy is valid on elements, right? We have many allotropic forms. For example, the most famous allotropic forms of carbon, right? Allotropic forms of carbon, right? Allotropic forms of carbon. So basically we have three allotropic forms of carbon. First is like diamond, as everyone is known about this. Second we have, which is graphite, and third is buckyball, right? Buckyball, right? So first diamond, graphite, and buckyball. These all have what? These all have carbon, right? They all have carbon. If they will react with oxygen, they will form carbon dioxide. For example, if we have G for graphite, or we can say diamond, D for diamond, if they react with oxygen, they will form what? Carbon dioxide, right? They'll form carbon dioxide. So it means they have same chemical. Basically allotropic forms have same chemical properties but different physical properties, right? But different physical properties. As diamond, as you all know, the diamond is the hardest substance known. So basically it has the structure which is basically tetrahedral. It has structure tetrahedral, whereas graphite has a structure hexagonal, right? Right, it has hexagonal structure. So like diamond is insulator and graphite is conductor, right? So they have different physical properties. They have different physical properties but same chemical properties, right? And this phenomena is known as allotropy, right? Allotropy. We have other examples too. For example, we have sulfur, right? My god, what's happening? We have allotropic forms of sulfur too, right? So basically we have alpha sulfur, we have beta sulfur, We have gamma sulfur 2. We have gamma sulfur 2, right? So basically this alpha has the structure of, right? Okay, so alpha sulfur has a structure which is basically rhombic. It is also known as rhombic sulfur. It's also known as rhombic sulfur. This beta sulfur is also known as monoclinic sulfur. Basically, it is quite needle-like. So these are basically the allotropic forms of sulfur. First is alpha sulfur, second beta sulfur, and third is gamma sulfur. Basically, gamma sulfur is also known as plastic. It is actually amorphous form. Plastic, right? It is also known as plastic sulfur. So this is what allotropy is. I hope this is clear to you. If you have any kind of queries, you can ask me in the comment section and I would be very glad to answer you guys.